You open an app on your phone. In 3 taps, you book a flight, reserve a hotel, and map the route from the airport. All of this happens on a single screen. We expect this level of integration every day. But as Sriram Gopalan details in his book, Bridge the Gap, which you can find at sgopalan.com/books/bridgethegap.html, making these systems talk to each other is incredibly complex. Imagine if Uber had to display a map, and their only option was to kick down the digital doors of Google's servers, rummage through their raw data, extract the exact coordinates, and build the map themselves. If every company did this, the internet would collapse. Google would have thousands of competing engineers stumbling through their private servers, accidentally deleting files or stealing proprietary code. The tech industry solved this problem by creating a strict middleman, the Application Programming Interface, or API. The modern internet relies on these APIs. Behind every seamless app is a network of isolated corporate vaults, safely trading specific pieces of information through these strict digital translators. To understand APIs, think of a high-end restaurant. You are the client, the hungry customer. The database is the chef, holding all the raw ingredients in the kitchen. Here is the system. Right in the middle is the waiter, your API. The top API documentation box acts as the menu, dictating what you can legally order. Following the arrows, the waiter translates your order for the chef and delivers the finished response. APIs enforce the strict boundaries that keep external clients away from the raw database. They protect the core infrastructure by ensuring every interaction follows the rules of the menu. Different digital tasks require different types of communication. You wouldn't use the exact same waiter for a fast drive-thru that you would for a 10-course tasting menu. This breakdown outlines different API architectures. The bottom panel displays REST, the classic model. Send one specific request, get one specific response. Above it, GraphQL allows the client to send a single flexible request, receiving exactly the tailored data they want in return. But GraphQL carries a hidden danger, known as the N+1 problem. If you ask an intern to get coffee for 10 people, a smart system batches the order into one trip. A poorly designed GraphQL query sends the intern to the database for Alice, comes back, goes back for Bob, and so on. 10 coffees result in 11 individual trips, creating a massive server traffic jam. Other specialized tools exist for specific jobs. WebSockets keep a continuous line open for live chats. Webhooks allow a system to call you back only when an event happens. And gRPC acts as a super-fast private intercom for internal microservices. Selecting an incompatible API architecture can lead to total system failure at scale. An inefficient protocol might function for a small group, but it will completely collapse the entire digital architecture once millions of simultaneous users suddenly begin making requests. Because APIs dictate how external users interact with internal data, they are the actual public-facing doors to a company's private infrastructure. When those doors are mishandled, the results are severe. In a major security incident, T-Mobile experienced a data breach that exposed the personal information of 37 million accounts. The root cause was an API left open without proper authorization locks. The company built the door, but forgot to verify who was turning the handle, allowing attackers to simply walk in and pull the data. APIs also function as binding business contracts. When Instagram suddenly altered its API limits, it restricted the menu of data external developers could pull. Overnight, third-party apps that relied on that exact flow of data broke completely. This is why managing APIs requires strict oversight. You have to ask if an app is overfetching massive data files to mobile phones, enforce rate limits so angry users can't crash the server by hitting refresh, and carefully manage version control so old systems keep working when you update the menu. APIs are the invisible glue of the modern digital economy. They allow competing companies to safely share resources, building a functional, interconnected web out of isolated data vaults. A technical decision about an API is actually a strategic business decision about organizational freedom, security, and scale. To learn the exact mental models that drive these decisions, check out Bridge the Gap by Sriram Gopalan at sgopalan.com and subscribe to our channel for more deep dives into the infrastructure powering our world.